buy hardware, do I? So in my case, I leased the server, and it's like 50 euros a month, and it's like four CPU, dual core, load of disk space, and it's good. So I won't advertise the hosting provider, but if you want to know, come and ask me afterwards. I wanted to do something that was open source, because when it comes to things like virtualization and cloud, there's a really kind of wacky thing going on as far as you have open source software, but these are all services. And so they have a certain amount of open sourceness about them, but typically that's the API. So you have an API, which they may say they've open sourced, but then there's a black box behind it, and you don't have any idea what's going on there. With projects, if you're going to share a project, unless I'm going to charge you all for it, which I haven't even sold it to you yet, then this should be something that, as a community, we can benefit from, and hopefully, if people like the idea, they can contribute back as well. So I wanted to do something that was open source, because the number of times I see security professionals recording videos or writing blog posts about, yeah, you've got VMware, ESX, or whatever. Well, at your company you might have that, and perhaps you run a copy of that at home or whatever. But I'm trying to do something that can appeal to everybody. So I'm not assuming that you've got money to go out and buy some of this stuff. And VMware, just to be fair to them, they do give away server products for free for non-commercial use. But the problem with that is that you're then tied to VMware's way of doing things. And whilst they're incredibly innovative, like there's no question on the virtualization side that they really lead, and they genuinely do innovation. I don't want to tie a project like this to a commercial product. It just doesn't make sense. And it should be free, and you should only be paying what you're using for, in my opinion. So, and then community project. I did a bad mistake, which was when I originally announced this project back in March, I asked for some volunteers and said, if you want to get involved. And then I disappeared off the face of the planet for a few months, which is not a very good way to engage and encourage community. And so, and I think apart from like being slammed with work and all the rest of it, I think part of it was I realized that I actually needed to get this out of my system. I needed to work on this, and I needed to get the first version out. And then it was like, then let people destroy it, rip it up, come up with something better. But just for the kind of the technical, get it out of my system, it was kind of like, yeah, if I make this a community project, then people are going to volunteer for stuff, yeah, and that's really good normally. But if you kind of need to get this out of your system, you find your droid, then maybe you just should put the first one out there and then let people trash it afterwards and come up with something that's way better. So so running it as a community project, I'm partway through developing it, and I'll show you what's there. And when it's finished, I'll put everything out there, and if people can do something with it, that's great, and if they want to contribute, that's brilliant. But obviously I'm hoping to be able to put out an implementation that people can just use. And then as the use cases get explored, people will come back with fixes and hopefully new features. So, where are we? Let's try that. So, bit about me. I'm not going to read it out, apart from to say I'm a proud member of the Eurotrash Security Podcast, and come to the podcasters meetup later. Did I already say that? Yeah. So that's 2 times. So 3 questions for you, and I'm going to ask you to put your hands up for this, please. First one is, do you use cloud storage? So that could be something like Dropbox or Amazon S3. How many people in the room are using some kind of cloud storage? All right, so that's about a third, maybe. And then, how many of you have booted a machine in a public cloud? So, for example, gone to Amazon EC2 and booted a virtual machine up. Just 1, 2, 3. So about 10, 12 or 13 people. And then, how many people have played with cloud network overlays, or VPNs, as you might want to call them, specifically in the context of cloud? It's always the guy that works for the provider that puts his hand up. So anyway, cool. Okay, thanks for that. So just, I don't know if you'll call that, but there was a third of you that have used cloud storage. There's a dozen of you that have booted a virtual machine in the cloud, and one guy who probably wrote the cloud network overlay. So that's kind of interesting, yeah. Like, we're information security professionals, and obviously we can't. Not everybody can do everything. So don't take this the wrong way. But you know, it's interesting that we're not using it more, yeah. That we're not finding out and kind of walking through the steps of doing this stuff. Perhaps we're not being asked by our employers about it, you know. But I just find it interesting. Every conference I go to, I ask these 3 questions now, and the results in Europe have been consistent, just like this. So anyway, this talk is about wannabe cloud troopers. So I'm trying to get you a little bit engaged in using some cloud services. I'm not sponsored by anybody to do this. I'm not an evangelist or anything. But if I can't twist your arm with some of the material that I'm going to be showing you, I will be giving away seashells as hats, just like in the picture. So, on-demand test labs, what's that all about? I've already described, you know, the situation where you need to be able to spin up a test network. And one use case I already mentioned is target practice. So, I think I've already covered that, really. Assurance testing. So this would be, you know, a new patch comes out. You need to be able to test it, and you don't have a test server handy, or the test server's busy, which is often the case. And you just need to be able to perhaps start up some kind of golden image of one of your devices, and you just need to be able to apply the patch and test it. Or it may be even better than that. You're not patching everything all the time because your operations are more mature than that. And it may be that you're looking at workarounds. So sometimes, you know, workarounds can be effective, but you need to test how effective it is. And so being able to spin up a kind of inflatable test lab when you need it, and then being able to just take the air out of it at the end and say, right, I did what I did, and I don't need that anymore. So another use case is during a pen test. It's quite possible if you're doing any kind of external testing, particularly if you're trying to get on the inside, is that it's quite useful to be able to have like random IP addresses and have those IP addresses for like enough time to send an email, for example, which may include particular attributes such as to exploit the target. So having like an IP that you can just have and then throw away, that's kind of cool. So being able to run a VM for less than an hour and maybe just pay like 10 cents for that, that would be pretty neat. Now you can do that today. I mean, there's nothing about Skylab to say you can't do that. You can do that with any, you know, cloud provider that offers that particular, you know, virtual machines. And so that's a great way to just dip your toe in. And so anyway, what's your use case? I mean, what are the situations when you would really want a test lab? You know, there must be some. There must be some projects that you're working on, or there must be some stuff you do at work where it would be really great to have a test lab. And so it's those use cases. And my use cases I just showed you, and that's where I'm coming from. But probably for somebody else, it might, you know, your requirements might be a bit different. But I've tried to come up with a fairly generic one. One comment about cloud and cloud services specifically is it's a commodity. And so therefore, for it to be a commodity and to get the price point that you do for paying for cloud stuff, that means it has, you know, certain attributes about it. And so you're getting, you know, x86 chipset. Yeah, you're not. There may be clouds that offer different chipsets, but I'm not aware of them. There is a GPU cloud, but from what I can tell, you have to pay a monthly fee before you can use that one, which doesn't seem very cloud-like to me. Anyway, so think of cloud as a commodity. So whether it's storage, whether it's compute, whether it's network, it's a commodity. And so you have to think about it as a throwaway thing, kind of. You know, another way is to think of it as disposable. So you only use what you need when you need it. So the context of this presentation is about infrastructure as a service. And there's 3 layers, and I talked about them last year. You have at the top layer, you have software as a service. And this is just a way to think about, you know, conceptualize these things. Software as a service, so Gmail or Salesforce. And then you have platform as a service. So for those of you that have heard of things like Google App Engine, and VMware, I think, are working on, with their SpringSource acquisition, I think they're looking at having a platform as a service. And then there's infrastructure as a service. And so the platform is aimed at developers, you know, plugging together kind of higher level APIs that are focused on, you know, business transactions of some kind. And then infrastructure as a service is your networks, you know, it's your tubes and it's your machines and it's your storage. So that's what we're talking about here, and that's the context of Skylab. So just to talk briefly about the design, there were some design principles, hit some common use cases I've already described. It should be on demand, yeah? I don't want to have hardware sitting around, I just want to be able to use the thing when I need it. It should be infrastructure as code, which is what all the cool San Francisco kids are talking about. Infrastructure as code is this idea that you can describe a virtual data center in a configuration file, for example. So you can say, my data center is composed of these networks that I've listed with these IP ranges, and it has on this network A, it has these virtual machines that are running these type of operating systems, and those virtual machines are either DHCP or they have fixed IPs. And so through a configuration file, you should really be able to say, or through an API call, you should really be able to kind of describe what kind of virtual infrastructure you're looking for. And that's cool, because if you had that, then I can share my network with you in the sense of my network design, my test lab design. I can share that with you, and if you've got the same code as I have, you can invoke all those. You can invoke that. You can inflate that test lab. It's yours because you're using perhaps the same public cloud providers that I'm using. Yeah, but it's not married to a specific provider, so it's got to be provider agnostic. On the subject of providers, though, when it comes to infrastructure as a service, there's a guy called Guy Rosen who measures and kind of tracks the number of cloud instances that are being spun up at different cloud providers. And when you look at his charts that he comes up with, it's like Amazon is the big gorilla. There's others, there's Rackspace and so on, but in terms of their market share, it's just like Amazon's this. And so inevitably, because they're so dominant, then they're the first one that I'm using for this. But I'll show you how the technology plugs into other cloud providers. Cost conscious. As I get older, I get more cost conscious. So I don't want to waste money. I don't want to, as I say, buy excess. I don't want to sink capital cost in for sure. And this cost conscious, this is, you can imagine your business leaders saying this. They don't want to spend what they don't have to. They don't want idle hardware lying around. And also hardware reuse. Like, not everybody wants to have everything in the cloud, and that's probably not what you want. I don't think. Put it this way: when I was thinking, how am I going to do this? I thought, yeah, I need like one server. You don't have to have a server, but you're just thinking, well, I don't want to run a bunch of VMs that I'm paying for 24/7 on a cloud provider, public cloud provider. I'd still want a base system where I can run some stuff on mine, and then when I don't have any capacity left, I want to be able to use their, I want to be able to use their services, but I want to be able to do it transparently. Like starting up a VM on my server should be the same as starting up a VM in, say, the Amazon cloud. Yeah. And then some other design principles. In terms of your servers, one or more servers that you may already own, that you might say, okay, this is my test lab, then you should be able to run any kind of hypervisor. So there's pros and cons to all of these, but let's not get religious. We need the flexibility, because someone might say, test this VM appliance, and it's in VMware format. Sure, you can do certain things with converting machine images, but it would be kind of cool if you've already got like VMware deployed. You kind of want to be able to just interact with that. So the technology that we're going to use for our cloud platform has to be able to talk to, say, VMware infrastructure. Has to be able to be agnostic about whether you're using Xen or KVM. KVM is the Linux kernel virtualization machine. And then the security test lab, I've already mentioned some of the features. So it should have visibility. I should be able to have certain things, like I always need a network sniffer on just about everything. So I should have a way to, spinning up virtual machines is nice, but then the question comes, so what? Yeah, what are you going to do with it? You have to be able to link them together, and you have to be able to configure them very quickly to be what you want them to be. You have to give them a personality. You have to install some software. You have to configure certain things. And so for a security test lab, there's certain things that you would want probably on every machine, yeah, or you would definitely want on certain machines but not other machines. So there's this notion of configuration management, which is what enterprises struggle with. You have masses of machines